So the next topic is advantages of SI system. So SI is a coherent system of units. SI is a rational system of units. SI is a metric system. SI is an absolute system of units. SI is an internationally accepted system of units. So speaking about one by one point in brief, SI is a coherent system of units. What is meant by the word coherent? So coherent means same, which means same for all countries. Okay, so SI unit is same for all countries. So it is a standard unit, that is a fixed unit. Okay, so SI is a rational system of units. So it is rational, it is not irrational. So it is equal for all. Okay, and SI is a metric system. So metric system, which is nothing but MKS system. So SI follows MKS system. So M stands for meter, K stands for kilogram, and G stands for MKS. Yes, M stands for meter, K stands for kilogram, and G stands for MKS. S stands for seconds. Okay, MKS system. So SI system follows the MKS system of units. It is an absolute system of units, which means it is a fixed quantity which is not ever changed, and it is internationally acceptable systems. Okay, so the next one that we are going to discuss is so let us see about some practical units. Small distances. Okay, for small distances there are certain units. For large distances there are some certain units. For small distances, 1 Fermi is equal to 10 to the power minus 15 meter. The screen is also displayed in the screen. Okay, and 1 extra unit is equal to 10 to the power minus 13 meter, and 1 angstrom is equal to 10 to the power minus 10 meter. 1 nanometer is equal to 10 to the power minus 9 meter. 1 micron is equal to 10 to the power minus 6 meter. Okay, and speaking for the large distances, the average separation between the earth and the sun is called 1 astronomical unit. So 1 AU is equal to 1.496 into 10 to the power 11 meter. Okay, so astronomical unit is nothing but the distance between earth and sun. So to calculate the larger distances, we use astronomical unit, and the value is 1.496 into 10 to the power 9 meter. And also we use light year to calculate the large distance. So light year is nothing but the distance travelled by the light in vacuum in 1 year is called light year, and the value is 9.46 into 10 to the power 15 meter. And also we use parsec, we call it as parallactic second. Okay, parallactic second, the distance at which an arc of length of 1 astronomical unit subtends an angle of 1 second at a point is called parsec. Okay, for example, before seeing an example, let us tell about the value first, and after that let's discuss in deep. Okay, so 1 parsec is equal to 3.08 into 10 to the power 16 meter. So if theta is equal to 1 second, then B is equal to 1 AU, then S will be equal to 1 parsec. Okay, so there are three large distances that we can use. One is astronomical unit, second one is light year, and third one is parallactic second or parsec. Okay, so these are the things. Okay, so next we'll discuss about indirect method, how to use this parallax method. Okay, to find the measurement of length. Okay, so now let's discuss that. So there are various methods. Speaking on it, see, now we discussed about the small practical units, right? For Fermi and all, we'll be using for measurement of very small nucleus like atoms and molecules. Over there we use Fermi. Okay, for angstrom we'll be using for x-rays and stuffs. For x-rays also they have given certain values. For nanometer we will use small nanoparticles, right? For small very small nanoparticles we will use nanometer to calculate or measure. Okay, and also micron we can use for measurement. Okay, so lot more things are there. So for prefix also is there for different things. Okay, when you take a prefix for nano, it is 10 to the power minus 9. When you take prefix for micro, it is 10 to the power minus 6. When you take it for milli, it is 10 to the power minus 3. Centi, it is 10 to the power minus 2. Deci means minus 1. Kilo means 10 to the power 3. Mega means 10 to the power 6. Giga means 10 to the power 9. Okay, so these are the some practical units. Okay.